We will begin now by showing our brief introduction of our methodology for the Safe Bank simulation.
First, we're going to discuss the design of our model. Our model consists of one source, one server, and one sink. There's also one model entity to represent transactions. The arrival rate was determined by using the provided data to calculate the average number of transactions completed per hour. In our Data tab, we have information for each client in the form of their assets under management and the probability that they will be carrying out a transaction. It was determined that each client is equally likely to complete a transaction. The client mix represents their probability of completing a transaction. We have three material elements. These material elements track the amount of US dollars, euros, and pounds in our system.
Now we're going to discuss the input data for our model. Some of the most important input data was the transaction amounts and the exchange rates. A summary for how this data was acquired is below.
We assigned a variety of functions for exchange rate and probabilities of currency exchanges. The exchange rate information was determined by using the previous year's exchange rate values and fitting the data to a normal distribution. The probability of each currency being entered for a transaction was determined by using the data and fitting the proportions to a normal distribution. Then we also determined the probability that if a certain currency was put in, what the probability that another type of currency would be pulled out. Again, this was fit to a normal distribution. Lastly, we determined the proportion of assets under management that each client exchanges in their transactions. Again, this was fitted to a normal distribution. For most of our normal distributions, we applied the central limit theorem and had the average value with the standard deviation divided by the square root of the number of observed samples. There were a couple of inputs we wanted for our model that we could edit each time. These included the initial currency quantities for dollars, euros, and pounds, and the swap points for dollars, euros, and pounds. After that, we also included swap amounts for dollars, euros, and pounds. Then we had our state variables. The state variables were used to track things like revenue, profit, opportunity cost, total money in the system, costs of swaps and settlements. We also set up state variables to track the number of times each currency goes negative. Next, we're going to talk about the processes for our simulation. The first process occurs on the path between the source and the server. We assign the currency type that is being entered in this transaction. Then, based on that currency type, we assign the amount that is being put in based off the proportion of the client's asset under management. The next process occurs at the server. First, we have a decide step that determines what type of currency is being put in. After that, we add that currency to our inventory. We add profit based on the 2 basis points that we get from the transaction, and then we subtract the currency that the client is taking out again from our inventory. The next process is the settlement process. This process occurs at the end of every day. In order to make sure this happens every day, we set a delay and then an event fire process. Once the event is fired, we determine which currencies need to be reset to their initial values. After this determination is made, we return the currencies to their initial values and subtract the money that we pay to the settlement party based on which currencies and how much were settled. The next process is the swap process. There are 3 swap processes for each type of currency. These swap processes are triggered when our monitor elements for each monetary value are set off. Once these processes begin, there's a delay to account the time that it takes to complete a swap. We also have a decide step that determines if we are still low on that currency value. Then we decide which currency to switch with. We do this by choosing the currency that has the highest value. Then we add the cost of the swap to our costs. The last process we have is a process to track the amount of times each currency goes negative. Essentially, we want this number to be 0 for each currency.
There's not much animation in our model, so we use graphs to track how our model is running. We have a graph to track the inventory of each type of currency as well as our profit. For verification and validation, we wanted to make sure our model was running smoothly. One thing we tracked was the total money in the system. We found that it was pretty much constant throughout the model, and that is what we had expected. Another way we did verification and validation is by making sure that each currency was being exchanged properly and that the revenue, cost, and profit were fluctuating with each currency transaction. Here's what it looks like when we run our model and track the currencies and profits with the graphs. You can see that the currencies are fluctuating and that they generally line up with one another. We will now discuss the results and recommendations collected from running the 4 required scenarios.
For our business as usual model, we were able to come up with the following amounts to have on hand that gave us the best profits. It was 5 billion in US dollars, 5 billion in euros, and 5 billion in pounds, which gave us a net profit of $136,864,000 by reducing our swap values and increasing our opportunity cost. The model that the bank currently used results in only $126,197,000. This shows that our process makes $10,667,000 more dollars each day. Since we already have high initial values, we can see that we already ensure there's always $1 billion of currency on hand, which is also great proof that our recommendation is low risk. From looking at our 95% confidence intervals, we see that the currency on hand for this best profit scenario ranges from approximately 1 billion to 7 billion.
In the trend away from one type of currency scenario, we adjusted the proportions of transactions in euros coming into the bank. We created an experiment and performed various scenarios until we found one with the best results. When comparing our best scenario to that of our business as usual values, we found an increase in the US dollars on hand, a decrease in the euros, and an increase in the pounds. We recommend that Safe Bank have 9 billion US dollars on hand, 2 billion euros, and 4 billion pounds. As the number of transactions in euros decreases, it is essential that we have these increases on hand for dollars and pounds. With the 95% confidence interval associated with these on-hand values, we have ensured that our profit will be maximized compared to other scenarios. In the loss of counterparty scenario, we disabled the ability to swap with our partner Globo Bank. When running an experiment with different scenarios, we found a best scenario. When comparing our best scenario to the business as usual values, we found that our best scenario values for initial US dollars, initial euros, and initial pounds were all less than the business as usual values. We recommend Safe Bank have 3 billion US dollars, 3 billion euros, and 2 billion pounds on hand. Using the 95% confidence interval with these on-hand values, we have ensured that we will maximize our profit.
For the end-of-day settlement policy scenario, we came up with the following values to maximize our profit. For US dollars, our initial amount was 8 billion, our swap point and our swap amount was 2 billion, and our settlement point was 4 billion. For euros, our initial amount was 3 billion, and our swap point and swap amount was 1.5 billion, and our settlement point was 3 billion. For pounds, our initial amount was 4 billion, and then our swap point, swap amount, and settlement point were all 1 billion. This led us to have a revenue of 2.09 billion, a cost of 153 million, and a profit of 3.8 billion. Overall, this was less profitable per day from our business as usual best case scenario.
In conclusion, we created a base model that would allow us to account for transaction values and a variability in an exchange rate. We created 4 different scenarios and then performed experiments of each. We collected statistical results and made recommendations to Safe Bank for each of these scenarios. We would like them to optimize their earning potential while operating successfully in a globally regulated market. Thank you.